Hey, 7th grade. In this next lesson, we're going to take a look at parallel and perpendicular lines and talk about how those go along with the rest of our unit over equations of lines. And so, first of all, we're going to talk about parallel lines. And one thing you may recall about parallel lines is that we define those as lines that do not intersect, or lines that do not cross. Okay, so if you have two parallel lines, that means they're never ever going to touch, or never going to intersect. And one thing that's special about parallel lines is that they actually have the same slope. That's the reason they do not cross, is because they're going up and sideways at the same rate. Okay, they have the same rate of change, so they have the same slope, and they also have different y-intercepts. If they had the same y-intercept, then they would actually be the exact same line. Okay, so that's the definition of parallel lines, lines that do not cross, and in algebra terms, lines that have the same slope. So for example, y equals 1/2 x plus 1, which is right here, and y equals 1/2 x minus 2, which is right here, are parallel because they have that same slope, 1/2. So to write the equation of a parallel line, like I have down here in examples 1 through 3, you just have to know that parallel means same slope. So what I've given you down here on 1 through 3 is I've given you a point and the equation of a line, and I want you to write the equation of a different line that is parallel to the one that's given, that also goes through the point I gave you. So for number 1 right here, let me break that down for you. You're going to write a line that is parallel to this one right here, parallel to y equals 2/3 x minus 1. The line that you write also has to go through this point here, 12, 5. Okay, well, let's think back to what that word parallel means again. Parallel means that lines have the same slope. So if we're writing an equation parallel to this line right here, then that means the slope of our line needs to have the same slope. So the slope that we use is going to be 2/3. Okay, so we know a slope that we're going to use. We also know a point, so we're going to use the point 12, 5. So thinking back to our last lesson, if we know a point and a slope, we can write an equation in point-slope form. Okay, the point-slope form of this line here would be y minus 5 equals 2/3 times the quantity x minus 12. And then looking back to the directions wanted us to write an equation in slope-intercept form. So the last thing we need to do is we need to translate this equation to slope-intercept form by distributing this 2/3 and then adding the 5 over. So the slope-intercept form of this line would be y equals 2/3 x minus 3. This line is parallel to this blue line. This line also goes through the point 12, 5. Notice I did not use this part right here. We did not use the minus 1, the y-intercept of the line we were given at all, because really that has nothing to do with the problem. The only thing we're focused on in this equation here was the slope of the equation. So sometimes in math you'll be given information that is really irrelevant. In this case, this y-intercept here is irrelevant. Okay, looking at number 2, this time we have the point -3, -1. The equation we're given is y equals 2x plus 3. So I know for a line to be parallel to this equation, it has to have the same slope. So that means it has a slope of 2. And the point that we're going through is -3, -1. So we're going to write an equation again in point-slope form. That would be y plus 1 equals 2 times the quantity x plus 3. Okay, to get that equation in slope-intercept form, I need to distribute my 2. That gives me y plus 1 equals 2x plus 6, and then subtract 1 from both sides. So this equation will be y equals 2x plus 5. Okay, finally for number 3, we have 7, -8 as our point, and y equals 4 as the slope. This one you have to do a little bit of thinking on, okay? Y equals 4 is a special kind of line. You should know this by now, hopefully, but y equals 4 is going to be a horizontal line. Okay, it's going to be a horizontal line through the point 0, 4. In order for a line to be parallel to a horizontal line, it also has to be horizontal. So for this one, there's actually a little bit less work you could do. Okay, we know the slope of the line is going to be 0 because all horizontal lines are 0. slope, but we also know that this line is going to be just y equals some number. Okay, some number, because it has to be horizontal, just like this line up here is horizontal. That ensures that they're both parallel. Well, the only way for this line to be horizontal and go through the point 7, -8, if you think about a coordinate plane. Okay, so we're going to make the point 7, -8. I'm just going to approximate and say 7, -8 is right there. Okay, the only horizontal line that goes through the point 7, -8 would be this line right here. And if it goes through the point 7, -8, it has to go through the point 6, -8, and -2, -8. Okay, every single y coordinate on that line is going to be -8. So that line would be the line y equals -8. Okay, that is the only horizontal line that goes through this point 7, -8. So really all I'm doing is, if I know the line's going to be horizontal, I'm taking the y coordinate of the point they gave me, and that's how I get the equation of the line. So whenever we're dealing with horizontal and vertical lines and we're given a point, it's very easy to write the equation of the line. Okay, that is parallel lines. Now let's go on to perpendicular lines. Perpendicular lines, the slopes are not the same. The geometrical definition of perpendicular lines is lines that intersect at right or 90-degree angles. Okay, so that's a definition you'll deal with a lot in geometry. Lines that intersect at right angles. For algebra purposes, we define perpendicular lines as having not only different slopes, but opposite slopes, and also reciprocal slopes. Okay, the slopes of perpendicular lines are both opposite and reciprocal. What that means is, if I have the line y equals 1/2 x minus 1, which is right here, a line perpendicular to that would have to have a negative slope. It would also have to have a slope reciprocal of 1/2, which would be 2. So the negative reciprocal of 1/2 would be -2. So this line right here would have to be y equals -2x. In this case, it's y equals -2x plus 2. Okay, so opposite reciprocal slopes is what gives you perpendicular lines. So down here in examples 4 and 5, what we're going to do is we're going to take two equations of lines and we're going to classify them as either being parallel, perpendicular, or neither. So for number 4 right here, I have the equation y equals -5/4 x plus 12, and then the second equation is y equals 4/5 x minus 8. So the slope of this first line right here is -5/4. The slope of the second line is +4/5. The first thing that we notice is that these are opposite slopes of each other. One is negative, one is positive. The second is 5/4 and 4/5 are both reciprocals of each other. So because the slopes are opposite reciprocals, we know these are two perpendicular lines. Okay, for number 5 here, I'm given an equation y equals 3/4 x plus 7. So I know that slope is 3/4. The second equation I'm given in standard form, so before I find the slope, I'm going to change this to slope-intercept form. I'm going to subtract that 4x from both sides. That gives me -3y equals -4x plus 9, and then divide both sides by -3. So this equation becomes y equals +4/3 x minus 3, so I know the slope of this line now is +4/3. And at first glance, it might be easy to say that these two lines are also perpendicular, but keep in mind, perpendicular lines have to be not only reciprocals, which 3/4 and 4/3 are, but also opposites of each other. 3/4 and 4/3 in this case are both positive. Because both of those slopes are positive, these are neither perpendicular nor parallel, so we're going to say neither for this one. In order for two lines to be perpendicular, you have to have the slopes being both reciprocal and opposite of each other. So for number 6 and 7 down here, we're going to do the same thing as we did in 1 through 3 in the front. We're going to write an equation in slope-intercept form that goes through this point here that you're given. But in this case, instead of writing an equation parallel to the line I gave you, we're writing an equation perpendicular to the one I gave you. So for number 6 here, I'm giving you the line y equals 1/3 x minus 1. We know the slope of this line right here is 1/3. In order to have a line perpendicular to this one, its slope needs to be the opposite. so it needs to be negative, and the reciprocal of 1/3. So the slope of the line we're writing has to be m equals -3. So we're going to take that slope, we're going to take this point, 2, 4, and now we're going to write our point slope form equation. So that would be y minus 4 equals -3 times the quantity x minus 2. Now I can distribute. And add my 4 over. So this line is y equals -3x plus 10. Finally, for number 7, we have the point 1,8. The line we're given is y equals 2x plus 1. So this line right here has a slope of +2. In order for us to write a line that is perpendicular to that, we need to have the opposite reciprocal, so that would be -1/2 for the slope. So we're going to take the -1/2 slope, we're going to take the point we're given 1/8, and one last time we're going to use point slope form to write the equation of this line. That would be y minus 8 equals -1/2 times the quantity x minus 1. We'll then distribute. And add our 8 over. So that's going to give us the equation y equals -1/2 x plus 8.5. Okay, any questions you may have over what we talked about in this video, feel free to jot those questions down. You may also email them to me so I can try to get to those the next time we see each other in class. Until then, have a nice day. You're all wonderful people. Take care.